So let's take a look at special relationships between lines and angles. A transversal is a line that intersects two or more lines. Could intersect 3, 4, 5, doesn't really matter. Typically it's 2, but in this picture, line T is a transversal because it intersects through lines L and M. When a transversal intersects through two other lines or more, it creates 4 special types of angles. So the first one is corresponding angles, and corresponding angles are on the same side of the transversal and in the same position. So for instance, they're in the top left position. So if you look at the angles formed on angle L, the top left position is angle 1. And from the angles formed on line M, the top left position is angle 5. So angle 1 and angle 5 are corresponding angles. There are 4 pairs of corresponding angles formed. So you could also do the bottom right position. So on the bottom right hand position from line L would be angle 3. And the bottom right hand position for line M would be angle 7. 2 and 6 are also corresponding angles, as well as angle 4 and angle 8. Alternate interior. So alternate means that they are on opposite sides of the transversal, and interior means they are in between the two lines. So in this particular figure, there are 2 pairs of alternate interior angles. There's angle 4 and angle 6. They're in between lines L and M, but they're on opposite sides of the transversal. And then you also have angle 3 and angle 5. Again, they're in between the two lines, L and M, but they're on opposite sides of the transversal T. Alternate, that means opposite, interior, inside. Likewise, we have alternate exterior angles. Alternate exterior angles are still on the opposite sides of the transversal, but they are on the outside of the 2 lines that are cut by the transversal. So in this case, they'll be on the outside of lines L and M. So the 2 pair of alternate exterior angles in this particular figure are angle 1 and angle 7. And then likewise, angle 2 and angle 8. They're on the outside of the lines, and they are on opposite sides of the transversal. The last special type of angle relationship that we have, and there's 2 different names. It kind of just depends on what book you're reading or what website you're watching or reading, what video you're watching. It's called, I typically say same side interior angles because I think it's more descriptive, but consecutive interior angles is also the other word. So same side means they're on the same side of the transversal. Interior means they're on the inside of the 2 lines. So in this picture, we have angle 4 and angle 5. And we also have angle 3 and angle 6. There are no same side exterior angles by definition. I mean, you could kind of go with that, that name and name those types of angles, but they don't, for some reason, they don't have their own special name. These are the 4 that you need to make sure that you know. And in normal just lines like L and M cut by a transversal, there's nothing special about these corresponding angles or the alternate interior angles, the alternate exterior angles, or those consecutive interior angles. But when your lines are parallel, there will be some special relationships. And so we're going to talk about that in a second, but we're going to go ahead and we're going to identify what type of relationship there is between these pairs of angles. And if it doesn't have one, then you just put none. So angle 1 and angle 8. Angle 1 and angle 8 are right here. They are on the outside, the exterior of P and Q, and they are on opposite sides of the transversal, so these are alternate exterior angles. I'm just going to use the angle symbol with an S. All right, let's look at the next pair. We've got angle 2 and angle 3. Those ones are on the inside and they're on the same side of the transversal. So this would be same side or consecutive interior angles. Oops. All right, next pair we got, let's see what we got next. We are looking at 5 and 7. 5 and 7 are in the same position. They're both bottom left. So these are going to be corresponding angles. The next pair of angles we're looking at are angle 2 and angle 7. So those ones are inside lines P and Q, but they are on opposite sides of the transversal, so these are alternate interior angles. Okay, next pair is angle 1 and angle 3. Those are in the same position, both top left. Those are corresponding angles. All right, we've got one more pair. The last pair is angle 6 and angle 7. So those are on the same side of the transversal and they are on the inside. So these are same side interior or consecutive interior. And again, you want to practice making sure you're comfortable with both words. As alluded, if your two lines that are cut by your transversal are parallel, then there's going to be something very special that happens with those 4 angle pairs. So your corresponding angles like 1, 5, 2, 6, 3, 7, or 4 and 8 are going to be congruent. Your alternate interior angles, 1 and 7 and 2 and 8, are also going to be congruent. I'm sorry, those are your alternate exterior. I think I said interior. Your alternate interior angles, which are 4 and 6 and 3 and 5, are going to be congruent. And your same side or your consecutive interior angles, that would be angle 4 and 5 or angles 3 and 6, those are going to be supplementary, which means they add to equal 180 degrees. Of course, you're going to have your other things that apply in all situations, like linear pairs, 1, 2, 2, 3, 3, 4, 1, 4. Those are going to be supplementary, and your vertical angles are going to be congruent, 1, 3, 2, 4, 5, 7, 6, 8. And that, again, is true no matter if your lines are parallel or not. So linear pair and vertical angles are true no matter if the lines are parallel. But if the lines are parallel, then you do have these 4 new relationships that will be true of your special angle pairs. So we're just going to finish up with a few examples with those, and then we will be done. All right, so in example 2, it says, given the measure of angle 6 is 142. So let's find angle 6. Let's label it 142. Find the measures of each missing angle, give your reasoning. All right, so let's start with angle 1. Angle 1 and angle 6 are vertical angles, so vertical angles are always congruent, so that's going to make the measure of angle 1 142 degrees. Angle 2 and angle 5 are going to be supplementary with angle 1 or angle 6. So if I add 1 and 2 together, or 2 and 6, or 5 and 6, or 1 and 5, the sum should be 180. So to find angle 2 or angle 5, I'm just going to do 180 minus 142, and that's going to give me 38. And angle 2 and angle 5 should have the same measure because they are supplementary to 1 and 6, but they're also vertical angles from each other. So 2 is 38 degrees, 5 is 38 degrees. All right, we know our lines are parallel, not because we were told in the words, but because of these little symbols right here. That means they're parallel. And so because they're parallel, then we have all these new angle relationships that we're looking at. So 1 and 3 are corresponding angles. So 3 should have the same measure as angle 1, which is 142. Likewise, because 8 is a vertical angle to angle 3, it should also be 142 degrees. 8 is also the corresponding angle to angle 6, so 6 and 8 should be the same. Or 1 and 8 are alternate exterior angles, and they are also, their measures are also equal. Then finally, 7 and 4 should have the same measure because they're vertical one to another. 2 and 4 are congruent angles because they're corresponding angles. So if 2 is 38, then that means that 4 is 38 as well. And likewise, 7 should also be 38 degrees. Forgot to fill in 6. So if you look at, and there's a lot of different ways you could come up with these angles. If you look at 2 and 3, the sum of 2 and 3 should be 180, and likewise 6 and 7 should be 180 because they are the same side or consecutive interior angles, which are supplementary. 3 and 6 are alternate interior angles, so they should have the same measure. 2 and 7 are alternate interior angles. They should have the same measure. So I can use all of these new angle pairs to justify why or how I got each angle measure. Our last example is a little bit more complicated because we have two parallel lines. We know they're parallel because of the parallel symbol right here. So those don't have names. I'm just going to call them L and M just to, if I need to refer to them, I can. But now we have two transversals. So I'm just going to call those transversals S and T. So it makes it a little bit harder to come up with your angle measures. It's not incredibly difficult, but you do have to be a little bit more careful. So we're told that the measure of angle 12 is 121 degrees. And we're told the measure of angle 6 is 75 degrees. So we're trying to find everything else. So the first thing I notice right off the bat is that angle 1 and angle 6 are going to be congruent because they're vertical angles. So if 6 is 75 degrees, then the measure of angle 1 is also going to be 75 degrees. Also, because of vertical angles, if 12 is 121, then angle 7 also has to measure 121 degrees. Okay, and then from there, I'm just going to try to put the pieces together. So I'm going to start with angles 8 and 11. 8 and 11 should have the same measure because they're vertical angles. To find those angle measures, they are supplementary to both 7 and 12. So 7 plus 8 should equal 180, and same thing with 11 and 12, or 7 and 11, or 8 and 12. So if I do 180 minus 121, that's going to give me 59 degrees, and that's going to be my measure for both 8 and 11. So 8 is 59 degrees, 11, 59 degrees. Okay. Angle 4. Angle 4 is corresponding with angle 11. So angle 4 and angle 11 should have the same measure. So if 11 is 59, then the measure of angle 4 should also be 59 degrees. And angle 3 is angle 4's vertical angle, so it should also have the same measure of 59 degrees. You can look at 3 and 8, their corresponding angles, so they should be congruent. We could have found angle 4 by subtracting 121 from 180 because angle 4 and angle 7 should be supplementary. So there's a couple different ways that you could find it using these special relationship pairs. All right, so now to find angle 2 and angle 5, first of all, I know angle 2 and angle 5 have to have the same measure. And the reason I know that is because they're vertical angles. So to find the measure for 2 and 5, I'm going to take, if I look at angle 1, 2, and 3, those form a line, so their sum should be 180 degrees. If I do 180 and I subtract 75, and then I subtract 59, that's going to give me my measure for angle 2, which is going to be 46 degrees. And then again, angle 5 is its vertical angle, so angle 5 should also be 46 degrees. Angle 9, there's a couple different ways to do angle 9, but for angle 9, it is the corresponding angle with angle 1. So if the measure of angle 1 is 75, then 9 should have the same measurement. So the measure of angle 9 is also 75 degrees. And likewise, since 9 and 14 are vertical angles, then 14 should have the same measure as angle 9. So that means 14 is also, whoops, not 79, 75 degrees. All right, so the last angles we have are 10 and 13. So we can do this a couple of different ways. I'm just going to use my linear pair rule. 10 and 14 form a linear pair. So do 13 and 14, or 9 and 13, or 9 and 10. So if I know that 14 is 75, then I know that 10, if I add angle 10 to 75 degrees, that it should give me 180. So 180 minus 75 is 105. So that is going to make up for angle 10. Angle 10 should be 105 degrees. And likewise, since 13 is a vertical angle, it should also be 105 degrees.